Well, good morning and welcome in. It's a kind of gloomy, as John said, gloomy and rainy Wednesday morning here in beautiful Taylor, South Carolina. And we're ready to go here for our CPT 168 class. The good news is next week is spring break, and looking at the forecast down the road, it's going to be a little nicer weather, I think, next week too. So I feel sure everybody will put that time to good use. We have a little bit of work to do this week before we get there. And so let's start by taking a look at the schedule and kind of see what we have left in our class. A couple of adjustments here. So this is week 11 of our 14-week semester. And today we're going to tackle dates and times, which is a very interesting topic. I think you'll enjoy this class or this unit this week. And then next week we have spring break, no classes. We get to catch up. I think of that as catch-up week. Then we'll come back and do a unit on dictionaries, a unit on recursion and algorithms. We'll have test 4. Notice that test 4 is on units 10, 11, and 12. And then we will also have, after that, we will have one more unit on building our own classes. So the question came up, I don't know if it was in this class or another class. It was another class. I remember who asked me now. But anyway, the student wanted to know a little bit about what to expect in the final exam in this class. Well, like most final exams, it is long. It is going to be covering all 14 units. So you will have seen most of the questions, if not all the questions. Well, I don't think anybody could have seen all the questions the way they're sorted and randomized and all, but you will have seen many of the questions in units 1 through 12 from the 4 tests. But units 13 and 14 will be new questions. So you'll have a little bit of both. You'll have, second time through on some questions, and you will also have some new questions from units 13 and 14. So I hope that kind of helps you understand. I'll give you a review sheet when we get closer to it, and we'll talk about some more. We may have time. I don't know if we'll have much time, but we may have some time for a review session, or maybe we'll do a separate class for a review session if you guys think that would be beneficial. I hadn't thought about it too much, but it's one thing that we can do since we're Zooming these days is just have a special study session for anybody that wants to go through some Q&A. We could maybe work something like that out. So anyway, that's coming up, and I hope everybody is, eager to get through this semester. But part of my concern is we have to finish the semester strong. We start looking too far ahead to summer and all the good things coming up down the road, getting our vaccines, our vaccinations, and getting out and about, and all of that is exciting. And but we want to be sure and bear down on our courses too and finish them strong. So in that vein, let me also remind you that we are registering starting this week for the summer and the fall semesters. I mentioned that last week. And if you need to or would like to talk to your academic advisor, be sure and do that before you register. I know that many of our students and my advisees have contacted me about advising, and so I'm a little backed up on that, and I'll be working on that some this afternoon, but probably mostly on Thursday and Friday this week, trying to get caught up on the requests for advising, because it does take some time to go through people's records and figure out what's what. But anyway, if you need advising, don't hesitate to reach out, but be sure and go ahead and register for your summer and fall classes this week, because when we get back after spring break, everybody will be able to register. So there'll be some competition from new students and transferring students coming into our college for seats in classes. There's not many sections in the summer. That is the way the administration wants to do this. So anticipating less students in classes in the summer, we have less sections offered. We'll see if that changes as time goes along here. But for example, we have 4 CPT 168 classes this semester. We only have 1 scheduled for the summer, which I find interesting. But I have a sneaking suspicion that there will be additional sections added as that one fills up, kind of understanding how the administration thinks. So if you have any questions about scheduling, send those to Mr. Cluley. He is the boss of scheduling, and he will be the one to take care of that. I really don't have many answers on scheduling anymore. So are there any questions about registration or what we're going to be doing for the next few weeks? Okay, so let's go ahead and get to work here. Unit 11 is on dates and times, something that's very important to developers. I will tell you that I've worked on dates and times in several languages, and by far it's easier in Python than any of the others. The methods that are created for us and provided for us for date and time management is huge. And so a lot of the work's already done. We just have to understand how to get the methods that we need, apply the methods that we want, and understand the logic of date and time. And we have a really good unit to help us get started on that. So there are 3 different ways that we can attack dates and times. We can do it with methods, and we have a special method that we can use for a constructor. And then we can also parse a string and convert a string to a date or time or date time. So parsing means reading. Okay, I don't know if you're familiar with that term, but parsing means reading. So we can read a string and then figure out or convert that to a object-oriented date time object. So another thing that we have to think about, and it's not really a big deal in this chapter, but it is there, is just distinguish between aware and naive date time and date time objects. When we say that, an aware object knows what time zone it's in. Okay, it has a predetermined time zone, whereas a naive is going to depend on the operating system for the time zone. Now, most of the time, we're going to use naive objects because we don't know exactly where our programs are going to be executed and run. So it's much more logical and also easier on us to just let the operating system handle the time zone. But that is the difference between a naive object and an aware object. And towards the end of this unit, we're going to get into spans of time, and that is where programming gets really interesting when you're dealing with months, days, weeks, hours, seconds, milliseconds, microseconds. Spans of time become challenging. Okay, so we're going to learn how to do that. We have a whole class of tools for that, and we'll get into the time delta class later on in the unit. And then we also have to be able to compare dates and times. That is really what we get paid to do, is to measure the length of time between 2 different objects. That's really what comparing is. We can go negative in the future, positive in the future or negative in the past when we compare dates and times. So there are different things that we can do that will apply to our programs that we write. Dates and times are really big in business programs too. So most of us will go to work for a company that will expect us to write business applications, specialized custom business applications. And so understanding how to deal with dates and times is going to be very important for that. Now, Python has a plethora of tools for us. We keep making that point over and over each week. And when it comes to dates and times, there are many modules, several modules that we could choose from. This book is going to tackle the most commonly used module, which is the date time module. And it has a bunch of stuff in it. So I think that we, as you progress and you go out into the workplace and you're exposed to other Python developers and other tools, you'll find additional time-related modules. But the one we're going to learn is the date time module, which is kind of the go-to module for this purpose. So the date time module is an object-oriented module. It has classes, constructors, methods, and attributes in it. And we're going to touch on all of those in this unit as we try to learn this. The good news is when we deal with these objects and these tools that we're going to use, we're going to be using a lot of the same syntax that we've already used. And that is what makes this so simple, so easy to learn, because we're just adding another layer on here. We have already learned some of this. And that is exciting to me as a teacher, because we don't have to reinvent the wheel here. We're just going to take some of the things that we have already learned and we're going to add to it. And that's the best way to get the job done. So first off, we're going to look at a couple of methods and 3 constructors to create a date object, a time object, and a date time object. So a date object has month, day, year. A time object has hours, minutes, seconds, milliseconds, maybe even microseconds. And then a date time object has all of it. Okay. Now, most rookie programmers tend to go to the date time object because they're scared they're going to miss something. And I totally get that. But as you will see in our first lab this week, that we want to streamline that just to be efficient, and we want to use the right object for the right job. So we need to understand what a constructor is versus some of these other methods that we're going to use to create objects. Okay. So in the context of date and time, when we use a constructor method, we're basically creating an arbitrary date and time, something that is fixed that we're going to compare to. And we're going to use Halloween as an example in this unit. So we have a date constructor, a time constructor, and we also have a date time constructor. And each one returns a different type of object, one that is relative to date, time, or date time. So before we can even do any of that, we have to import the right module to get to the classes, to get to the tools, okay? So the first thing we have to do is import the date time module. And then from that module, we have to make sure we import the constructors or methods that we need to use. So as you study this unit, pay close attention to how that is handled in the examples. And it's not in all of the examples. Some of the examples, he kind of jumps over that. But towards the end of the chapter in the big program for this week, you'll see that it is dealt with for sure. So a class that we would get from the date time module is going to contain the constructors and methods that we need to create the objects. So we'll want to sometimes import the date object, the date class, or the time class, or the date time class. Or we could import all 3 of them if we wanted to, and we could do it different ways. And we'll see a couple of ways to do that. So 2 of the most common methods that we are going to deal with throughout the whole unit are the date from the date class, date.today, which returns an object for the current date. Okay, just the current date. Very common in programming. And then there is the datetime.now object, which is kind of the same but different. Okay, first off, it comes from the date time class, and now the now method is going to return a date time object, which is going to include the current time and the current date. Now we can also use the methods to create particular dates and times using the constructor method. Okay, so for example, if we want to set the date for Christmas, everybody knows it's December 25th. It's easy to use birthdays, holidays as examples. So we wanted to create or construct using a constructor method. We would do use the date method down here, and it takes 3 parameters in this order: the year, followed by the month, followed by the day. Now, if you want to be terribly careful, and I tend to be that way when I'm dealing with a lot of different methods, remember we can go to named arguments. We don't have to just put them in the right sequence. So, but most of the examples in the book are sequence oriented. In other words, all of the values are going to be in the correct sequence, but occasionally he sprinkles in some named arguments, which I think are really easier to read and understand. He deals with that in the chapter too, by the way. Down here, we have the same thing for time, the hours, the minutes, the seconds, and then the microseconds if you want to get really, really particular. Date time is the whole enchilada. It's the date and then followed by the time. Okay, so some examples of that. First, let's see how to import this from the date time module. Import date, the date class. From the date time module, import the time class or the date time class. That takes 3 lines, a lot of typing. We could do it with 1 line. And this is probably what you're going to do. From date time, import date, comma, time, comma, date time. Now, you don't have to import all of these. It depends on the scope of your program. What do you need for the program that you're writing? But if you did need all 3 classes, this is how you would do it. So let's look at some constructors, okay? So first off, we want to create a date object here called invoice date. And we're going to do that by using the date class and the today method. We talked about that just a second ago, and that's all you need to do. There's nothing inside the parentheses that will return the current date as the invoice date object. Same thought process, but a different class and a different method. So the date time class, the now method, and that will return a date time object, which is the current date and the current time. Here are the constructors I was talking about, and all 4 of these do essentially the same thing. Halloween in 1988 was on 10/31, and a meeting may start at 2:30 in the afternoon. One thing that I forgot to talk about yesterday in class, today I will remember. When we're dealing with hours in the time objects and date time objects, we're going to be dealing with a 24-hour reference to hours. Now, if you've not been in the military or not done any programming with other languages, you probably are not familiar with this. Just realize PM, all the PM hours are going to be greater than 12. And so if you want to reference them or speak of them as, in this case, 2 o'clock in the afternoon, you just subtract 12 from 14, and you see the 2 is left over, and that's going to be 2 o'clock in the afternoon. And if you're going in the other direction, you have to add 12 to the hour to get to the 24-hour clock. It's not too complicated, but some students have never done that before, and we'll make sure you know how. Now, look at these date time objects with all the arguments they have. Lots of things to set. That bothers me. This is where I would really want to consider using named arguments rather than just putting them in sequence here. But for the time being, we're just filling in the values for the parameters arguments that are expected in the order that they are expected by the method. So that's a little bit difficult in my opinion. But you can see the constructors. Now, once we have the constructors imported into our program, especially if we do all three of them, we kind of have a open field here. We can do any of the constructors that we need. We can use any of them. Now, another way to do this is to read a string and convert it to a date time or date time object. And the best example of that is the one that's in the book, where you have a prompt in your program and you ask your user to enter a date for something, enter their birth date, I think is the first example, or enter the, at the end of this unit, we're going to do a hotel reservation program, which is really cool. And we're going to ask for two dates, the arrival date and departure date. Okay. So those are strings. So we can convert that string to a date time object, okay, using the right method, using the right tool. And so that would be the strp for parse time method. Now be very careful as you start learning this, because strp, that P, the fourth digit there, is very important, because that stands for parse, and that converts a string to an object. We're going to go in the other direction too, but it's going to be different, okay? So right now we're going to parse. So we're going to parse a string to time. So strp for parse, or read a string and convert it to a time object, okay? And some examples of that are coming up. We also have the ability to create date and time objects that go out to milliseconds and microseconds. Realize that a millisecond is 1/1000th of a second, but that's not totally good enough for us. We want microseconds, which go to 1/1,000,000th of a second. Now, in business programs, we're not going to do much of that. No. Thank goodness. But if you write a scientific program, yeah, you will. So you need to know that that is available, but conveniently, we won't use that in too many business programs. Also realize that by default, all of these objects are naive. They don't have any context, any sense of time zone or daylight savings time for that matter. We depend totally on the operating system for that. There is a way, it's not really discussed in this chapter very much, to get TZ info. There is a parameter for it in date time and time constructors, okay? But we're not going to worry about that too much, because that is not done all that much. Typically, we would let the operating system take care of the time zone. Now, there are two arguments that we supply the string parse time method, okay, the strp time, so string parse time method. The first one is the string that we want to parse. And the second argument is going to be the format for the time. Now, that brings up a whole nother can of worms, because we got all kind of issues with format. The good news is we can create a date and time or date time object in the format that we want. It is very flexible, but with flexibility comes complexity. So there are a bunch of codes that we have to get familiar with, and some we will use more than others. And these are commonly available codes. These are the same codes we use in Linux and Unix and in some Microsoft situations. So this is not just a Python thing. As a matter of fact, John and I'll be in a Linux class later today. John's in this class. And the formatting for the date command in Linux uses the exact same codes that we use for the time format in Python. So they're fairly universal. I don't want to say they're 100% universal because there's always an oddball, but pretty universal. So here are some of the codes, but not all of them. We actually on, I think, slide 15 have more codes. But so first off, let's take a look at the string parse time method. And so it is in the date time class. We have to have that imported for it. So datetime dot strp time, so string parse time. First, we need the date time string and then the format. Okay. So notice all of the codes start with a %sign. That's the first thing. That's easy to remember. The second thing is much more complicated because notice we have upper and lowercase characters, alpha characters, and that is important. These are very case sensitive. And to the point, let me show you this. I noticed this. Notice that percent lowercase m is month as a number with a leading zero. So January would be 01. And then we go down to percent m, it's all about minutes as a number. So we completely got out of the month business and got into the minute business. That's crazy. So that one kind of drives me crazy because they changed the whole meaning for the letter M. But that's not always the case. Most of the time, the upper and lower case determines whether it's a short form or long form of whatever part of a date time object you're talking about. And you'll see that as we go along. So in this example, or this group of examples here, we have 4 different strings that we are parsing to create objects, date time objects in these formats. So once again, we have to use the datetime class dot string parse time, and we're going to create an object. They're all named Halloween here, just for example. And notice these are enclosed in quotation marks, so we know they're a string, okay? And notice that these are, and I think this is a little bit misleading here. All of these examples have these formats in the same format as the string we're reading. It doesn't have to always be that way, okay? But many, many times it is. If your users are following directions and the prompts that you have in your program, you shouldn't have to do any conversion of the format, just conversion of the string, or change the string to an object. So here's an example of what I'm yammering about here. So we want to create an object here, date string, and we're just going to use the import function, input function to do that. And we have an instruction here for our user. We gave them a nice format. Later on in this unit, we're going to start checking that format. And it's not that complicated. We're going to use exception handling that we learned earlier in our course a few weeks ago. And that is going to be a part of your labs this week, to take a non-validated program and start validating dates and times, because that is very important. You have to validate this stuff or your users are going to screw up your data big time. So we import this string here. And now we want this date string to become a birthday. So from the datetime class, we're going to use the string parse time method for the date string, and we're going to use this format. So that's going to be a 2-digit month, a 2-digit day, and a 2-digit year. No, 4-digit year. That's an uppercase Y. That's a 4-digit year. So that is going to be the format that we want. That's 4-digit year right there. If I would just look at the screen, I would know what I'm talking about. So here's the output in a console. We enter 2/4/1968. It's almost when my son was born. Well, pretty close. Within a year. Anyway, so here is the birthday. And notice we created a we created this birthday object, and we are printing the birth date. And I noticed this yesterday because the output here is unformatted. So I think there's a mistake in the book here. And you would have to test this to see, but I think this object here, birthday, is going to be in that format. And so when we print that object right here, it ought to be in the same format. I think we have a mistake right there. So as you're studying, and I need to do that, I forgot to do it yesterday, I'm going to check it and see. But I am pretty sure that's a mistake in the book. If not, I stand corrected, but check it and see. Every once in a while you find mistakes in books. All right, so we were taking a string and creating an object there, okay? So what about in the other direction? This happens. There are many times that we will want to take an object, in this case, a date time or date time object, and convert it into a string. So we have a method for that also. And that is the, don't need that. I need this, the strf time method, which is string format time. So just pack it away in your brain cells there that the string format time method is going to create a string, okay? It's taking an object and changing it to a string. And it uses the same codes and stuff that we have in the past. I don't think we have any problem with that. So strf time uses the specified format string to convert a date time object to a formatted string. So that is going to be handy. So now on slide 15 here, we got a ton of these codes. Some of these are repeated from the previous group that we looked at. So here is uppercase Y for a 4-digit year, and lowercase y gives you a 2-digit year. Okay, so that's where I messed up a minute ago. But one that I will call your attention to is lowercase b and uppercase b. I like these because sometimes I want to get away from numbers for months. So lowercase b is the short form abbreviated month name, and uppercase B is the month all spelled all the way out. We can do the same thing with A for days, okay? And another one that's interesting, and a student asked me about this yesterday, percent lowercase p is our AM PM specifier. So that is a way to convert a time or format a time as AM or PM, which kind of gets that to a familiar place. Also, we have a code for microseconds, %F. If we want microseconds in our string or in our object for that matter, going in that direction, %F will do that. Now, below this blue line here are 3 that they want us to pay special attention to. %C, lowercase c, is a really interesting code because that returns the date and time formatted for your locale. Remember, we studied locale, just a few days ago. And so we import locale into our program and set it up. Then we can change the format very simply for our date time objects. And so %C will take advantage of that locale in your program. We can also do that with date and with time, okay? C is the date time object. I didn't say that. It is a date time object including the day of the week, whereas lowercase x is the date formatted for the locale, and uppercase X is the time formatted for the locale. So those can be kind of handy for us as we write our program. So just remember %C specifier, a code. I just like the word code because it is a code. Prints the current date and time in the common or the current locale that is set up in your program. and the lowercase x and uppercase x do the date and the time respectively there. Okay, so some more examples of this. Back to Halloween. And notice in our date time object that we're creating here, this is a constructor. We are going years, months, days, hours, minutes. The one thing about the sequence of these arguments or parameters is they go from the largest, which is years, to the smallest, which is microseconds. So if you think of it that way, possibly that will help. So now we've created a date time object here. And it's got 1, 2, 3, 4, 5 pieces of data in it. Now we can convert that to strings. Okay, so using the string format time method on the date time object, we can format it. And so notice we are setting the format for these objects. And this is where we can change the way it looks. Okay. Even to the point down here, we have the %P. So we added a AM or PM at the end. And I like this. We have the % uppercase A here in parentheses. And so we formatted the day of the week inside parentheses here. So different little tricks. I'm sure you guys will figure that all out. If we just want to see what Halloween is in the local locale, %C, or if we want to use locale for the current date, okay, date format. All this is about format. Just remember string format time method. And so that's converting an object. And in this case, Halloween is an object. We created it up here. We are converting that object back to a string and we're formatting it in the process. Powerful stuff as it applies to date time objects. Any questions before we jump into time delta? I have learned to pause a little bit longer when I ask for questions because it takes people time to find the mic button. I got interrupted a couple of times yesterday. I was going too fast. Okay, so let's dig into spans of time. Now, up to this point, we just kind of been learning the tools. Now we're going to start doing some work with those tools. So there is yet another object that we can create called a time delta object, which is a span of time. It can be very short. It can be really, really long. That's irrelevant. It is a span of time. And so if we have a span of time or a time delta object, then we can do math with it. And this is the part that blows me away about Python, because this is not difficult. In other languages, it is much more tricky, let me say, to deal with, but it's not really that hard in Python. So we can add spans of time, we can subtract spans of time, we can store spans of time. Cool stuff. So there's a constructor that we can use in the time delta class that is very detailed. It can accept up to 7 arguments. We saw 5 arguments takes us up to seconds, okay? Time delta can go milliseconds and microseconds and take us up to 7 arguments. So evidently that's the number that triggers Murak, because now he says, okay, maybe you want to use named arguments instead of just doing sequence. And I got no problem with that. I like named arguments. And as he says, named arguments make it easier for people to read your code. So you're going to see some named arguments in these examples. So let's dig in here. Time delta is the constructor in this case, the constructor method. And we can start off with days, and notice we are out of sequence here. We're kind of jumping around. So days, seconds, microseconds, milliseconds. So, and then we're jumping to minutes, hours, and weeks. So one thing that I want to point out, I think that we are going to be consistent with all of these names here in the time delta objects or time delta constructor, that they all end in S. Now, little things like that are important to me, and I hope that they're significant to you, because that will help you not make any mistakes. So just realize when you're dealing with a span of time, we are dealing in plurals of units, okay? So we have to be sure and import the time delta class from the date time module. So once again, we refer to the date time module. We want to import the time delta class. Once we've done that, we have the constructor, and all these are constructors. And then down here, we're doing math with it, okay? So time delta, in this case, is going to be weeks equal 3. So that's creating a time delta object here. This is a 3 weeks object. Got the same idea here for 2 hours and 30 minutes. Time delta hours equal 2, minutes equal 30. Or time span, which is a popular one, is a time delta object. It's going to be 2 weeks, 3 days, 8 hours, and 14 minutes in our example. And then down here, we can just use simple arithmetic or mathematic operators here and add these objects, subtract these objects, add these objects. This is so cool. So from the date class, we have the today method, which creates an object. So we want to add time delta weeks equal 3 to it. So notice we don't even have to convert these to objects. We can do it with the methods and add them and create a new object here. That is so cool. Here's one for today. We want to subtract the time delta of 3 weeks. So we're going backwards 3 weeks ago. And here's the date time class dot now. So that gives us the date and the time. So the time delta 3 hours, we're going to add 3 hours to the time of this date time object. This is not complicated. This is actually super easy, much easier than it is in my also favorite language, PHP. So the book calls these arguments attributes. So now we call these values, parameters, arguments, and now attributes. They're all the same thing. I don't know why we do that, but we do. So just realize we're playing with words. If there's one thing that Python does, has a lot of words, okay? So notice they're all plural, and we have one additional method that we haven't talked about, and they sneak it in here at the bottom of this list, total seconds. And we know it's a method because it has the parens after it. So that is going to give us the total number of seconds and microseconds, not milliseconds, but microseconds. So that will convert a time object or a date object, date time object, into a total number of seconds in microseconds when we apply this. And that is very scientific and very exact. And we'll see some examples. Actually, we have a neat little program we're going to work on that deals with that. So that'll be helpful. So let's look at how to work with spans of time a little bit more here. We're going to use the date time constructor here to create Halloween, and then we can do some math with it. So Halloween minus the date time class dot now method, and that will give us the time span between dates. Just that simple. We are going to compare now with Halloween in 2017. And notice we subtracted. So that will give us a time span since then. So sometimes I would suggest that you play around with pluses and minuses and look at the output. I think you can learn a lot from testing these tools, playing with these tools, and seeing what happens, because it changes substantially. So you should do that. So we're creating a few more objects here: days, seconds, microseconds, total seconds. Just an example of how to use these tools. Remember, we created a time span object here, which is Halloween minus the date time now. So we can run that object into the days method, okay? And come up with the number of days, the number of seconds, and the number of microseconds, or for the total number of seconds. I'm going to back up here a second. I want to show you what we are basically doing here. We are referring to these attributes here, okay? Attributes, days, seconds, and microseconds, and also a method. So another way to look at this attribute thing, and I didn't say this yesterday, I should have, but it behaves like a method, but it does not have the parens. Okay, that really gives me a headache, but it does. It behaves like a method, but it doesn't have the parens. And so that's what we're seeing here. Okay, so we have the time span object, and we want the days attribute. So what that is doing, the time span object here has the days attribute in it, okay? So we just want to pull out just that part of the object. Maybe that will help us understand. See what I'm saying? So it's not really a method, it is an attribute. I want that piece from inside the days object, or excuse me, the time span object. We can pull out the seconds. We can even pull out the microseconds, okay, because it's a date time object, okay. Now, total seconds does require a method. It's still on that date time object, which is time span, but we have to run do a little math, I guess. So as a method to pull that out and come up with the total seconds and microseconds. So the microseconds is the remainder, okay. That's really the leftover part, as we will see. Now, once we have all these values here, then we can print them and do things with it. And this output to the console, here's the days, the seconds, and also the microseconds, actually, right here. And then here's the total seconds dot and the microseconds, which we can get that return just by doing total seconds. That is actually what this value looks like. It's seconds and then a dot and the microseconds left over. Very, 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 very exact. Okay. Now, here's another way to do kind of what we did up here, okay? You could do it this way: days equals Halloween minus the date time class now method, okay? Put that calculation inside parens, then pull out the days attribute. That would also get you actually right over here, days. So that's kind of a combination of this line and this line together. So, and that's just because we put this calculation or this part of it in parentheses. So we're using things that we have learned earlier in the class. Any questions about the working with time span? Either you've nodded back to sleep or you're getting it. Hopefully you're getting it. Once again, I'm sure many of you are thinking I'm going to have to do the labs to really understand this, and that's true. And we're going to use it more in the remaining units that we look at from time to time. We'll get back to date time and date time objects. All right. So, yep, definitely. It's easier to get these things by doing it. What I am trying to do in these classes, and I hope we are working on this, is I'm trying to at least warm you up here, at least give you a preview or a preface so that you can be looking for certain things, okay? Joshua asked, is total seconds afloat? And that actually was a similar question yesterday too. And I'm going to answer it exactly the same way. No, okay? This is a object unto itself. It is not a number. It's not an integer. It's not a decimal. It is not a floating point value. This is a date, time, or date time object. Horse of a different color. It is not the same thing. Okay. Yeah, it kind of looks like it might be, but it's not. As a matter of fact, total seconds is very exact. It is very exact. There's no floating going on at all. So I think that even though you see digits, these are not integers. These are not floats. These are not decimals. Okay. Good question. That's interesting. We got that 2 classes in a row. All right, so let's look at a little example program. We'll kind of build on these programs as we do in most of our units. First off, an invoice due date program. And so this is a very simple little program. The user only enters an invoice date. And I like the way we give them some instruction here on the format that we want, okay? And we need to learn from this. Don't leave your users hanging here. Tell them exactly what you expect. So they enter a date, okay? And notice that the program we are going to look at is going to reformat that date. It's going to figure out a due date, basically adding 30 days to it. And then the current date is going to tell you what the date is now, okay? So by comparing the date to now with the due date, we can do a calculation and write this information here, which is very interesting. This invoice is 30 days overdue. So a lot going on behind the scenes here. And then we are running a while loop here so we can go through it. Again, so first off, from the date time module, we want to import date time class and time delta class. Okay, so look at that line and understand what we're doing there. We're bringing in 2 classes. We're going to create a function here for getting the invoice date. And first thing we need to do is get a string, the invoice date string. We're going to do it exactly like we saw in our little example about birthdays. Use the input function and get that string. And then we're going to have to parse it and convert it to a date time object. So from the date time class, string parse time method, that invoice date string, and we want to put it in this format, okay? Then return the invoice date. Then we get on to the main function here, heading, then our while loop. And so we'll run the get invoice date function we just created to get the invoice date. And now we can do our math using the methods that we just learned. So the due date, okay, is going to be the invoice date plus a time delta of 30 days. That's how we added 30 days to the invoice date object, which we created right here. And then the current date is just going to be the now method in the datetime class. And then the days overdue is going to be current date object we just created minus the due date we created up here. And we want to pull off the attribute for days, just the days, okay? And then we just print this stuff out. All this is just printing. And notice how we have converted the objects here, invoice date, due date, and current date, back to strings, okay? And when we did that, we changed the format. So this code right here, the purpose of this code is to take the objects that we had in memory and change the format from them. That's really all we did here is change the format. And then down here, the little sentence about whether it's overdue or not, we have an if-else statement. So if statement, else clause. So if days, okay, days overdue is greater than 0, then print this invoice is days overdue. Okay, we calculated days overdue up here, days overdue, else days due, okay, which is a new object. We're actually creating that object here, is a days overdue times -1. Now, what do you think that times -1 is doing here? Okay, I'll tell you, it is converting a negative to a positive, okay, because the days overdue still calculates the time delta between the two dates, but we want to make this days ahead, okay, so it's got to be converted to positive. And so that's done with a -1. And then this invoice is due in so many days due that we created right here, days. We got a couple of strings we kind of put on the beginning and end there. So, and then I have a blank line. We finish out the while loop here. We've seen this code before, so I don't think we need to discuss that and the if statement there to make sure this is the main module. Any thoughts about that interesting little program? Because I got another one for you. All right, so another preface here. To understand the timer program, also could be called a stopwatch program, we're going to use the input function without any input. And all we want to do is stop the program, prompt the user, and then move the program on to the next line of code when the user presses the enter key on the keyboard. I think that is so cool because they figured out that the input function really does not have to have any input. We are only going to use the part where we press the enter key. And by default, it just goes to the next line of code, as we've seen a million times already. So that is just like hitting the button on the stopwatch. So press enter to start. And yeah, we're going to have code that creates an object based on that. That'll be the start time. And then press the button again to stop. That's going to create a different object, which is going to be the stop time. Then we can do some math to come up with the elapsed time and format it. You're also going to work on this in lab this week. So let's get to it. Here's the code. Once again, we need to import from the datetime module, import datetime and time. Now, interesting thing here. I noticed this yesterday. Where's the time delta class? We're not even going to use the time delta class here. We're just going to do math, okay? So first, we'll look at our main function. There's the name of our program. I changed timer to stopwatch. I think it's cooler. But anyway, start the timer. Here's our input function, and all we want to do is press the enter key, and that will create a datetime.now object from the datetime class. Now is the method, and that will create start time. Print the start time and a blank line, and then do the same thing for the stop time. So simple. Same thing again, just different names. Okay, now we can calculate the elapsed time. The elapsed time is going to be the stop time minus the start time. Okay. And then we can get the days from this elapsed time object that we created here by, since this is a date time object at this point, we can get the days attribute from it. So we get the days. Here we get the seconds. Now, since we aren't using time delta, we got to do math. So // is an integer division by 60. So we divide the seconds by 60 to get minutes, okay? And then we can do the remainder. That's what the percent here is, the remainder operator to get the seconds, okay? After dividing by 60, what is the remainder? And then we can also pull off the microseconds as a attribute. So elapsed time attribute, microseconds. Now, I have a question in my mind looking at this. Why did we not do minutes and just use the minutes attribute? We know it's there. We didn't have to do this math. And the seconds, we could actually do that as well. Okay. So I'm assuming that Murat just wants to teach us some math here. So we could use attributes like we did here, or we could do math. We did an attribute here. I don't know. I am just the messenger. All right, so calculate hours and minutes. So hours is going to be minutes divided by 60, and minutes are going to be minutes, remainder 60 again. Once again, doing the same type of math. I'm still puzzled. We can do that a different way. And I think the only thing that is gained by this, okay, the only thing that is gained by this is these become integers. The data type changes when we do math this way. And these become integers. So that may be why he did it that way. All right, so now we are going to create a time object. We're going to create, they're using the time constructor here, hours, minutes, seconds, and microseconds that we calculated. So now we have a time object, okay? So you guys were asking about floats. Okay, we're going to integers here. We're changing the data type. Now we can display. So print elapsed time. If days are greater than 0, then print it out if it has days in it. So that's kind of an interesting question, because how many times does a timer go over 24 hours? I guess a timer program might, whereas a stopwatch would. So maybe that's the difference. And then print the time object, the time object here, which we created from those integers, and then the if statement to make this the main module. Any thoughts about this little program? Getting those objects is pretty easy. This is different here. I wonder if you could do this without going to integers and just do this with object oriented all the way through. I don't know. Didn't think about that yesterday or Monday. That's a new thought. All right. That's the thing about date, time, and date time objects. There's just so many different ways you can deal with it. So now we have, we've learned about the constructors. We know about the classes. And we know how to create date time objects by specifying integer values, which we just did in that previous little program. So now we're going to look at how to get those integer values from a date time object, which actually is what we just did, but we're going to do it a little different. So back to attributes, pulling attributes out of an object, okay? We've been doing this. Now we're doing it officially, okay? So notice these do not have an S on the end. These are attributes as compared to arguments, which we saw in the time delta with the S's. So these are attributes, and they are fairly easy to understand: year, month, day, hour, minute, second, and microseconds. So, and we've already seen this. In this example, we are building a date time object with the constructor here. 1, 2, 3, 4, 5, 6 different values here. They're not named, they're in sequence. So we can pull them out with the attributes. And these are the attributes that are at the, after we reference the object, dot, and attribute. So we can pull each of them out. And that makes these integers. And that is absolutely what we were doing back here in our program with this code. The light bulb has finally gone off and I understand what I've read. I'm a student too, man. Some of these nuances kind of evade me when I'm speed reading, and now I finally get it. It's okay to make a mistake as long as you fix it. All right, so how to check a date and time parts, once again, dealing with those attributes. So today we're creating a date object using the today method from the date class, okay? So if today.month attribute equals 10 and today.day attribute equals 31, print happy Halloween. Else print, dang it, it's not Halloween today. Silly little program, but you see how we're using the attributes, okay? Code that creates a new date based on the current date. So we establish the current date here. Last year, we are going to get an integer here, going to the today object, the year attribute, that becomes an integer, -1. That means last year is going to be an integer. 1 year ago today, so that can be done. We're actually creating an object here using the date method, okay? So last year plus today.date and today.day. Now, these three values are integers, and this is going to be a date object. All right, because we use the date method to create it. All right, so code that creates a new date and time based on the current date and time. So now is going to be a date time object using the now method. So we can pick apart those parts using the attributes again. This time last year, so using the date time method, we're going to pull out these integers here to create this new date time object. Now dot year plus 1, so that'll be next year, okay. Now dot month, now dot day, now dot hour, now dot minute. So that would create a new date based on the current date and time 1 year from now, because we are doing +1. Okay, now hopefully I didn't get you guys too confused on that. Has anybody got any questions about converting pieces of a date time object using the attributes? Integers, creates those as integer data type. I think we're in the home stretch here. Now we are going to compare date time objects. We're going to figure out what the time span is between certain dates and times, okay? And so here's some code that compares two date objects, start with. So we create a today object using the date class and the today method. And then Halloween, we're using the date constructor method to do that. So if today is greater than Halloween, print this. Else if today is less than Halloween, print this. Else if today is equal to Halloween, then this. So a quick little example of how to use a method to get today's day as an object, to use a constructor to create another date to compare to, and then we use these comparison operators here to figure that out, okay? Code that prints the number of days until Halloween. We can actually do some math here. So once again, we create a today object and a Halloween object, okay, using the date class, today method, the date method here, okay. This is a constructor method. And inside that, we are pulling off the year number, the integer for the year, off of the today object, Okay, so if today is greater than Halloween, which we know from this object we created, next year today dot year plus 1. So that's going to add a year to the year integer. So if today is greater than Halloween, we're going to create the next year, and then we're going to create Halloween for next year using that next year integer that we created above here. And then we can do days until that. So Halloween now is next year. I wish they'd changed the name of that object. It would have been easier to track this. So this is now next year's Halloween. So next year's Halloween minus today, and just pull off the days attribute, and we get the days until then and print it. Okay. Any thoughts? Yeah, man. Okay. We're going to compare a couple of more date time objects here. And this is just a real simple little business program. And I'm not even going to point out the stuff because we're just doing the same thing over and over again, except we're using the time delta here. So we create a meeting start object using the date time constructor. Okay, that's the scheduled time the meeting is going to start. Year, month, day, hour, and minutes. And then using the time delta, we're going to figure out the meeting end because the meeting is supposed to be 1 hour. So time delta hours equals 1. We want to add that to the meeting start. And then we have to have a now object, which we do that from the date time class now method. And then now we can do the comparisons. If now is greater than the meeting start and now is less than the meeting end, then print the meeting is happening now. Else if now meeting is less than meeting start, the meeting is coming up. Else if meeting is greater than meeting end, the meeting has already taken place. So do you see how we created these objects? I lied to you. We'll point this out. These comparison, the greater than comparison, less than, greater than. So we are comparing objects here to come up with some meaningful dialogue for our program. Any thoughts? Okay, so the next example, this one's getting kind of interesting because it has a mathematical problem that we have to fix. Next example uses comparison operators like we just saw to adjust a 2-year digit, to adjust a two-digit year, excuse me, to adjust a 2-digit year. I was getting ahead of myself here. So the first statement is going to get the string for the birthday. The second statement is going to parse that string and convert it to a date time object. Now here's the problem. If the user enters a year in the 1900s, this converts the year into 2000s because we have crossed a century. So for example, if the user enters, and it's a 2-year digit problem because we don't have the first 2 digits to straighten this out. So because we're dealing with 2 digits, the user enters 2468. Well, that's going to be calculated as 2068, which makes this person really strange, not 1968, which would be the correct birthday. So make a note back in the back of your mind. Be careful with 2-digit years. Be very precise. Go ahead and waste 2 digits and have a 4-digit year, and you wouldn't have to deal with this problem. But if you have a 2-digit year, here's an example of how to fix it. So to fix this issue, the code is going to adjust because if the year is greater than the current year, then we have to subtract 100 from it, okay? So to fix this issue, the code checks whether the birthday year is greater than the current year. And if it is, then it subtracts 100 from the birthday year. So if it was 2068, we would subtract 100 to get back to 1968. Now this is great, but people are living longer now. And if somebody is over 100 years old, this system doesn't work. So go back to 2 to 4-digit years, get away from 2-digit years, and you wouldn't have this problem. So here's the code that's going to fix this. And I find it interesting that they put this in the book, but it's more practice using the tools, I guess is the whole point. So code that automatically adjusts the 2-year to be correct. So get the input and convert it to a date time object. So here's where the mistake starts, right there. And we parse the string to come up with the birth date, and we put it in the right format here. We're still lowercase y's 2 years. If necessary, subtract 100 to fix the birth year. Okay, so if birthday is greater than datetime.now, okay, if it's greater than now, so if they were born in the future, right? If it's greater than now, they were born in the future. This is a birthday. A little hard to be born in the future. So fix birth year, birthday year minus 100. So that's where we subtract it. Birthday is the object, year is the attribute, minus 100. That creates a integer object. So now birthday is going to be converted to a date time object using that integer, fixed birthday year, fixed birth year. And then we'll go ahead and have integers from the birth date month and the birth date day using those attributes. And that creates a new birthday here that is less 100 years. Now we can print birthday and add to it the birthday dot, and just all in one foul swoop here, we're creating a string is basically what's happening here to concatenate onto this string here. So we have the response we see down here. And notice we're going to an uppercase Y to fix our mistake and get back to 4-digit years. That little brain teaser took a little bit of doing. I thought it was interesting. Don't know if it's totally necessary, but what happens if you run into a program somebody else wrote and you have to fix it? There you go. All right, we're in the home stretch. We've got 5 and 8 is 13 minutes to go. We'll probably be right on time here because I want you to really study the hotel reservation program for a couple of reasons. One thing that I want you to think about here is this program uses a lot of programming that we have learned in 11 units of study. It is a fairly powerful program. It does a lot of calculation. It does meaningful work for a company. And I want this to at least raise your confidence level a couple of clicks, because you could write this program. You could write this program or even a harder program because you know a lot of what's going on here. Plus, I'm going to point out some neat little tricks. Every time you read a program, you need to figure out what the writer of a program is doing so you can learn their secrets, okay? So let's assume we are running a hotel and we want to calculate the charges, the fee for staying in our hotel, right? So the user is going to enter a arrival date and a departure date. We want to figure out how much it's going to cost. So we enter 2 dates, and we're going to see that this hotel has 2 different fees based on the time of year. And high season, I guess, is a hotel term maybe for high volume or something, but this is when supply and demand is in the hotel's favor, so they charge more for their rooms 4 nights, and this is the total charge of what it's going to be. So you're saying that's a pretty simple program. There's actually a lot going on behind here. Okay, so let's kind of go in here and see what it is. So we need to import from the date time module the date time class. That's not too brutal. And also import locale, because this could be an international program. Now, right off the bat here in this first function we're going to write, we're going to do exception handling. And this is another good example of why we do exception handling. We should do that a lot. Data validation should be way up our list of things to be really good at, okay? So we need to do data validation whenever possible because there's one thing we know about users: they're not going to follow directions and they're going to make mistakes, and we need to, quietly push them in the right direction without our program crashing. Without this exception handling, it would be easy to crash this program for this hotel, and we do not want that to happen. So we start off with a while statement here, and we accept a string. We've seen this already, so a date string. But now we're going to run it through a try statement and make sure that we have a good value, okay? So arrival date, we want to use the date time class that we imported, and string parse time method, that date string that came in, and put it in this year dash month dash day format that we expected, okay? Make sure it's in that format. If we get some kind of value error, okay, remember that's one of those broad ones, then just print on the screen invalid date and continue. The continue statement goes back to the top of the current loop, which is this while loop, and starts over again and asks them to input a correctly formatted date. Okay, once we have that correctly formatted date and we have created an arrival date time object, we can do some stuff with it. So we want to strip non-zero time values from the date time object. So now it's going to be the now method of the date time class. And today is going to be using the attributes. We're stripping from the date time using the date time method here. Now is going to be the year in this order. In other words, we're building today as a string, basically. So now dot year using an attribute, comma, now dot month, comma, and now day. So today is going to have those three attributes. Okay. So now we have a if statement to make sure that the order of these days is right. So if arrival date is less than today, you have to print arrival date must be today or later. Try again. It has to be a future date, today or a future date. Once again, continue, goes back to the top, starts over again. Else return the arrival date that we have created. So, and we actually created arrival date right up here. All right. Moving on to the departure date, this should be almost identical. The logic changes, but the syntax is very similar, okay? So we're working with less than or equal to for the comparing the departure date with the arrival date. So it could be, I guess, for one day, but typically it would be some other date further down the road, right? And come up with a departure date. Now we get to the main function. We print the name of the program, and we calculate the arrival date and departure date dated based on those two functions we wrote. Print a blank line. So here's the 11-month out of the year rate, 85.0. Okay, so that is a float. And so that is how much it costs when you're not in August. Okay, August is the high season. So if we have to figure out if the month is equal to 8, so we got to pull that out of the arrival date object. Okay, so here's the arrival date object we created. And so if arrival date dot month, getting the month attribute, those attributes are very handy. That equals 8, then we're going to change the rate. Remember, rate started here is 85, but now rate's going to be 105, and we're going to have a rate message. I've jumped over this line. We initialize rate message as blank here after we did the rate, because if it's null, then we don't want anything on the screen there. So now rate message is going to equal this string here, parens, high season parens. Total nights, easy to calculate, departure date minus the arrival date, and we just want the days attribute. The total cost is going to be the rate, whatever it is, either 85 or 105 times the total nights. Then we just need to format the results and we can print it on the screen and we look like geniuses. So the date format, we are setting up a string here that is going to be the codes for our date format the rest of the way. I thought this was a really neat technique. We don't have to do it this way, but we have a lot less typing. So this creates a variable here, which is a string of these characters that can be interpreted as a format when we run it through the string format time method. We saw this earlier in our course. We want to set the locale. So this is the general locale based on the operating system, so we don't have to guess. So this should set the locale correctly. And now we can start printing. And so the arrival date object is going to be changed to a string using the date format string as the template. Okay. Do the same thing for the departure date. The nightly rate is going to be based on locale. We get the correctly formatted currency for rate and the rate message if it is required. Okay. So this is the locale class currency method for rate. Okay. Then the total number of nights is pretty easy. It is, we just want to print the number, the integer that was entered for the number of nights, actually not entered, but calculated. And then the total price, we calculated that, the total cost. We also want to run that to the locale class and the currency method. Then we just finish out the while loop and the if main statement at the end that we have done so many times. Okay. That's a pretty neat little program. Okay. Anybody in this class should be able to kind of hammer that out with a little bit of trial and error, I think. And I'm not saying you're going to get it right in the first hour of trying to figure it out either. I know it's going to take some time, but you have seen all of this. Okay. I'm going to go back to the beginning. So this is where we're trying to get, okay, a lot of output, and we did some exception handling. We figured out how to acquire this date properly. We did data validation. We acquired the second date and we did the data validation. We formatted it the way we wanted. And then in the main function for this program, we dealt with 2 different rates based on the month. It could have been 12 different rates based on the month. You know, we just did one. We did the math to calculate based on the rate. We learned how to put a message on the screen that was not always there because the rate message is null until it is required. So when we did our output, and notice it was to the right of the rate. So we were basically using wasted space on the screen. It was not being used for anything else. So there wouldn't be a blank line there by accident, is what I'm trying to say. And then we formatted everything nicely. We took the locale into consideration and we printed our dates. So are there any questions about the hotel reservation program? "11 weeks and we got this far." Okay. If you have a question later, let me know. So we have a few terms. None of these terms are killer terms. These are easy terms to remember because they are, some of them are repeat, like constructor, class, object. Those are repeats. But understand that we want to be able to know these terms in reference to date time objects. Here's our Cliff Note summary. We're going to finish right on time. So this week, I want you to read and study chapter 11 really good. Download these slides if you think they'll be helpful for you. I keep encouraging you to warehouse a set of slides. I think they paid dividends. I may make a change on that typo. I need to figure that. So maybe wait till tomorrow to download the slides. Because if I'm correct, I need to fix that. And let's see, topic 11 in our discussion board, do that this week. And also 2 labs. You're going to work on that invoice due date program and the timer program. You're going to make them better, okay? And a quiz. Now, because you guys have been such a good class, if you look at the due date for this week's assignments, you got till the end of spring break, all the way to April 4th. So you get that. You don't have to send me a thank you note. A little extra time to work on it. That may be of help to you. I don't know. But please don't procrastinate and wait till the 4th of April to do it. That would not be good. You got plenty of time. So enjoy your homework, work on it and learn from it. Don't put it off to the last minute. Are there any questions? Okay, everybody wants to go. Okay, I got you. All right. So if you have any questions, send me an email. Otherwise, have a wonderful spring break. Please be very careful. I have been known to have students in the past 18 years that got sick or had an accident. I'd already had one student this semester have a serious car accident and messed up his legs. That's not cool. So please be very careful. I'm kind of like worrier. I worry about everybody. So be careful. Have a good time though. Do something fun. I plan on doing it. We should have some nice weather. And we'll meet back here in 2 weeks and continue on our journey through the vast wasteland of Python. No Zoom next week for sure, John, that's for sure. The Zoom machine will be off next week. Yep, I'm going to try to catch up on a lot of things during spring break, including some things around the house. I have a honey-do list that's longer than it should be. So you guys have a good week off, and we'll see you in 2 weeks. Until then, take care.